Hello everyone. Today we'll be looking at some quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2019 Test 4A Paper 2 Code C and D. So let's start with the first section. This section contains 10 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 21. It says the D subshell has 5 orbitals that are dxy, dyz, dzx, dx square minus y square and dz square. So looking at the options, we can clearly see that the examiner seems to be interested in the shapes as well as the energy of these d orbitals. So we can first talk about their shapes. So we have 5 different orbitals. And if you try and draw them, we'll first try and draw d, x, y, y, z and zx. So if we talk about dxy, the dxy is going to have lobes along the angle bisector of the axis. So this is the dxy orbital. If we talk about dyz, so these three have exactly similar orientations. And dzx. So these are double dumbbell in shape. So this was dyz or dzy. This is dzx. We can talk about dx square minus y square. So the dx square minus y square has lobes along the axis. So these are also double dumbbell in shape. But if we talk about dz square, the dz square orbital has lobes along the z-axis. And there is a ring present in the xy plane. So if we talk about the shape of these orbitals, we can clearly see that the 4 orbitals which are drawn above, they are double dumbbell shape. They have a similar shape. Whereas the 5th one, which is the dz square, it has a different structure than the others. So if you look about the options concerning the shape, so we have the A option is correct and we have the C option is incorrect. Now we can talk about the energy. Now in absence of the electrical and magnetic field, all these 5d orbitals are degenerate, which means that they have the same energy. So if we look at the option B and option D now, we can see that option B is incorrect as it talks about the energy of the 4 orbitals being different from dz square. Whereas if you look at the D option is correct, which says that energy of each d orbital is same in the absence of electric or magnetic field. So students, we have to select option A and option D as the correct answer to question number 21. Let us look at the next question. Question number 22. Select the correct statements. So students, in this question, the examiner seems to be interested in the preparation of silicones. So let us start with the first option. Methyl chloride react with silicon in presence of copper at 573 Kelvin to form MeSiCl3, Me2SiCl2, Me3SiCl and Me4Si. This statement is correct, students. Methyl chloride will react with silicon in presence of copper at 573 Kelvin to give us the various substituted products. Let us look at option B now. Hydrolysis of dimethyl dichlorosilane followed by condensation produce a straight chain polymer. So if we look at the structure of dichloro-dimethylsilane, so we have Si-Me-Me Cl-Cl. So if we talk about the hydrolysis, it is going to generate the structure in which the chlorine will be replaced by OH, and when they are subjected to polymerization, they will produce a straight chain polymer. So we can condense the 2 units and we'll have the 2-dimensional polymeric structure. So students, statement B is also correct. We can look at option C now. The chain length can be controlled by adding Me3SiCl because Me3SiCl blocks the end of the polymer. This is also correct, students. The Me3SiCl on hydrolysis will generate the structure in which the Cl is replaced by OH again. And when this is condensed with the straight chain polymer, it will cause the chain termination of the straight chain polymer, as it cannot further undergo polymerization because the ends are blocked. So students, statement C is also correct. We can look at statement D now. The silicones are water repelling in nature and have high thermal stability and high dielectric constant. So students, this statement is also correct. This is the most important property of silicones. So they are water repelling and they have high thermal stability and high dielectric strength. So students, we can see that all four of these options for question number 22 are correct, and we have to select all of them as the correct answer to this question. Let us look at the next question. Question number 23. Which of the following statements are correct? So in this question, the examiner talks about the alkali metals. So in the first option, the examiner talks about the stability of the carbonates and the hydrogen carbonates of first group element. So he says that the stability increases as we move from top to bottom in a group. So students, this statement is correct because the carbonates and the hydrogen carbonates are large anions. So large anions are generally stabilized by large cations due to lattice energy effects. So as we move from top to bottom, the size of the alkali metal ion increases, and as such, the stability of the carbonate and the hydrogen carbonate increases. Let's look at the B option now. Hydrogen carbonate of lithium does not exist as a solid. This statement is also correct, students. We've just seen that the stability increases as we move from top to bottom. So the lithium bicarbonate is not very stable and it does not exist as a solid. If you look at option C and option D now. So in option C and option D, the examiner talks about the delta HF values for the halides of the alkali metals. Students, if we talk about the formation enthalpy values, so it is a combination of a number of factors. We know about the Born-Haber cycle. So we can just roughly write it down. So we have M solid plus X2 gaseous. We can have half X2 gaseous in general. And we can talk about the formation of MX solid. So if we look at the steps involved, which is the Born-Haber cycle itself. So the M solid will first sublime to give us M gaseous. That M gaseous will lose an electron to form M plus gaseous. Now if we talk about the halogen, we'll have to first dissociate the bond to form gaseous atoms, and the gaseous atom thus formed will accept an electron to form X minus gaseous, and thus M plus gaseous and X minus gaseous will combine and give us the MX lattice. So we can see that there are a number of steps involved in this reaction, and the delta H naught value will be a result of a combination of all of these factors. So it becomes fact based that the delta H naught value for fluorides become less negative as we move from top to bottom in first group, majorly because the lattice energy decreases as we move from top to bottom. Now if we talk about the D statement, delta H naught value for chloride, bromide and iodide become more negative when we move from top to bottom in first group. This statement is also correct, students. It is a combination of various factors like I already said before, and both of these statements are correct as per the facts. So students, the correct answer for question number 23 are all of these options. So we have to mark A, B, C and D as well. Let us look at the next question. Question number 24. A salt of an element of first group gives lilac-violet coloration to the flame. The element reacts with excess of air to predominantly form a yellow-orange colored compound P. Select the correct state. Students, if we talk about the flame coloration by the alkali metals, the lilac-violet coloration is provided to the flame by potassium. So the element may be potassium. So option A is correct. If you look at option B automatically becomes incorrect. Lithium does not provide lilac-violet coloration to the flame. In fact, it provides crimson red coloration. Next, the examiner seems to be interested in the yellow-orange colored compound P. So we've already established that the element may be potassium. Now when potassium is allowed to burn in presence of excess of oxygen, we can have a series of compounds. We can have the normal oxide, which is K2O. We can have the peroxide, which is K2O2. We can have the superoxide, which is KO2. Now if we look at the compound P which is formed, obviously the compound under question has to be KO2 because it is yellow-orange in color. The superoxides are paramagnetic. And it is in fact the major product formed when potassium is allowed to undergo combustion in presence of oxygen. So the compound P is KO2. If you look at K2O and K2O2, both of these are colorless species and they are diamagnetic in nature. Now the examiner seems to be interested in the hydrolysis of the compound P. So when the compound P, which is KO2, it is allowed to react with water, we're going to have the formation of KOH, we're going to have the formation of H2O2, and we are going to have the formation of O2 as well. So if we talk about the oxidation state of the oxygen in the product side, we can have -2 in the KOH, we can have -1 in the H2O2 and we can have 0 in the O2. So if you look at option C now, which says that the compound P on hydrolysis formed different compounds in which oxidation number of oxygen are -1, 0 and -2, we can clearly see that this statement is correct. So the statement D will automatically be incorrect, which says that the oxidation state of oxygen is only -2. Students, for question number 24, we have to select option A and option C as the correct answer. Let us look at question number 25 now. In question number 25, the examiner has asked us to select the correct statement about the structure of ice. So in the first option, the examiner seems to be interested in the number of hydrogen bonds which are formed by the water molecule in its solid structure. We know that the water molecule can form 4 hydrogen bonds. So there are 2 lone pairs over oxygen and then there are 2 hydrogens. So both of these lone pairs will form hydrogen bonds and both of these hydrogens will also form hydrogen bonds with the adjacent water molecules. So the total number of hydrogen bonds formed is 4. So students, the first statement is correct. If you look at option B now, each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms with 2 different distances between oxygen atoms. So students, the first part is correct, that it is surrounded by 4 other oxygen atoms. But there are not 2 different distances. All of the water molecules are symmetrically arranged and the type of OO bond distance present is only 1. So if you look at option C now, the option C says each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms with same distance between all the oxygen atoms. So statement C will be correct. And if you look at statement D now, each oxygen atom is surrounded octahedrally, so this is also incorrect. So there is no octahedral surrounding. Each oxygen atom is surrounded by 4 other water molecules and the distance between all of these oxygen are also same. So students, if you look at the options, we can clearly see that we have to select option A and option C as the correct answer to question number 25. Let us look at the next question now. Question number 26. Atoms Q and T are interacting to form bonds, which may be sigma or pi. The compound formed is not necessarily diatomic. If the z-axis is taken as the internuclear axis, the correct statements regarding the formation of a bond is. So students, the examiner has mentioned to us that the z-axis has to be taken as the internuclear axis. If you look at the options, so in option A, the examiner says that the px orbitals can form pi bond. So this statement is correct, students. Along the z-axis, there will be the formation of sigma bond. So pzq and pzt will form the sigma bond, whereas pxq and pxt will form pi bond, and the pyq and pyt will also form pi bond. So if you look at the options, option A is correct and option C is also correct. Now if you look at options B and D, in option B the examiner says that the d x square minus y square atomic orbitals can form sigma bond. So students, the x square minus y square orbitals have lobes along the x and the y axis. So they cannot form a sigma bond as there can be no direct overlap as the internuclear axis is along the z direction. So the internuclear axis is along the z direction and the given orbital does not have any lobe along that axis. So students, statement B is incorrect. We can look at option D now. dxy and py atomic orbital can form sigma bond. Again students, the dxy also does not have any lobes along the z-axis. It is present entirely on the xy plane and as such it cannot form a sigma bond with the pyt. Also the pyt does not have any lobe along the z-axis. So they can only overlap to form a pi bond. So option D is also incorrect. So students, for question number 26, we have to select option A and option C as the correct answer. Let us look at question number 27 now. Question number 27, it says sulfur, nitrogen and fluorine form a compound X which contains 31.1% sulfur, 55.33% fluorine by mass respectively. If the molar mass of the compound is 103 gram per mole, then select the correct statement about X. Students, we can figure out the empirical formula of this structure. So we have sulfur, fluorine, and then we have nitrogen. So if we look at the percentage composition by mass, the amount of sulfur given to us is 31.1. The amount of fluorine given to us is 55.33. So if we talk about the percentage composition of nitrogen, we just have to add both of them and subtract that number by 100, which will give us a value of 13.57 for nitrogen. So this is the mass ratio. We can divide them by their molar mass to get the molar ratio. Let's call it as N. So we're going to have approximately 1 here, approximately 3 here, and approximately 1 again. So we have the empirical formula now, which is SnF3. We can talk about the molar mass. So one formula unit contains 32 plus 14 plus 57 grams, so which is equal to 103 itself. So the compound under consideration, the compound X, is SnF3 itself. Now let us talk about the structure of SnF3. Students, sulfur obviously has to be the central atom in this case because nitrogen cannot expand its octet and fluorine can form only one single bond. So if we place sulfur at the center, we're going to have the nitrogen triply bonded to sulfur, whereas the fluorines will form sigma bonds with the sulfur. So we have the structure of the compound X. So in option A, the examiner seems to be interested in the total number of lone pairs. So sulfur has no lone pair in this case. Nitrogen will have one lone pair, whereas each fluorine will have 3 lone pairs. So the total number of lone pair will be 3 into 3 plus 1, which is equal to 10. So students, the statement given in option A is correct. If you look at option B now, the hybridization of central atom in X is sp3. So the sulfur forms 4 sigma bonds. So it will be sp3 hybridized. So the statement B is also correct. X is a planar molecule. This statement is incorrect, students, because the sulfur here is tetrahedral. If you look at the D option now, one molecule of X contains 4 sigma bond. This statement is also correct, students. We had already used this fact to find out the hybridization of the central atom. So students, for this question, we have to select option A, option B, and option D as the correct answer. Let us look at the next question now. In question number 28, the examiner says, classification of elements into groups and development of periodic law and periodic table are the consequences of systematizing the knowledge gained by a number of scientists through their observations and experiments. One of the fundamental classification is done by Mendeleev. Select the correct statement about Mendeleev's classification. Option A says, Mendeleev arranged the elements in horizontal rows and vertical columns of a table in order of their increasing atomic weights in such a way that the elements with similar properties occupied the same vertical column, which is also called as a group. Students, this statement is correct. If you look at option B now, Mendeleev left several gaps in the table. This is also correct. The examiner seems to be talking about the eka silicon and the eka aluminium. So statement B is correct. If you look at statement C now, the properties of the elements are a periodic function of the atomic weights. This is correct, students. Mendeleev based his periodic law on the fact that he believed that the properties of elements were a periodic function of their atomic weights. If you look at statement D now, he did not strictly follow the increasing order of atomic weight during the arrangement of atoms and placed the elements with similar properties together. So students, this statement is also correct. So all 4 of these statements are correct for question number 28, and we have to select all of them as the correct answer. Let us look at question number 29 now. Consider the following oxide. So we have been given a list of oxides. The examiner further says that these oxides can be divided into 4 categories, which is acidic, basic, neutral, and amphoteric. So we have to select the sets in which all oxides belong to the same category. So if we look at the first option, in option A, the examiner has clubbed Al2O3, AH2O3, PbO, SNO, PbO2, SNO2. So if you look at them very carefully, we can clearly see that all of them are amphoteric in nature. So this option belongs to the oxides which are amphoteric in nature. If you look at the second option now, N2O5, Cl2O3 is talking about the acidic oxides. So N2O5 is acidic, Cl2O3 is acidic, GeO2 is also acidic as per NCERT. PbO2 is not acidic, it is amphoteric, and CO2 is also acidic. So the 4 of these oxides were acidic, but the 5th one is not. The PbO2 is not acidic, it is in fact amphoteric. So this is incorrect. If you look at option C now, in option C the examiner has clubbed CO, NO and N2. All of these are neutral oxides. So they also belong to the same category. And if you look at the last option now, Na2O. Na2O is basic. CO and N2O are neutral. So they do not fit in the same category. So this option will also not be correct. So if you look at the options very carefully, we can see that the oxides given in option A are all amphoteric, whereas the oxides given in option C are all neutral. So for question number 29, we have to select option A and option C as the correct answer. Let us look at the next question now.